All right, so welcome to Eureka Math Squared. This is grade 6, module 5, lesson 13, and we're dealing once again with surface area, but this time in real world situations. So today's page is 217 and 219, but we'll actually start on 219 first. So let's cruise on down to 219. There it is, 219. Okay, so here's 219 page. Here we go, 219. And this is, I guess a very typical type questions. We have a box. It's in the shape of a right rectangular prism, and it doesn't have a lid, so there's no lid. And they want to know how much cardboard do we need? Well, if we're making a box out of cardboard, this is surface area. Okay, so this is a surface area question. Okay, because I need to find the area of this face, this guy over here, this face, and then of course the bottom, but not the top because we're not actually dealing with the top. This is an open box. So let's see. I have some dimensions here. Okay, there's a length, there's a width, and there is a height. Okay, so I have to calculate for the amount of space, surface area for the front, right? The front and the back. Those are identical. So let me start with that. Okay, so I have a front and a back, and two of those, right? Two front and backs, they are the same, and I'm using the 6 and the uh, 3.5, or the length and the height, right, to calculate for that, or those two. Now I need, let's see, I get rid of all that. Okay, my little circles, get rid of those guys here, put that back. And how about these guys? I need the left and the right. Okay, so I need the left and the right. And for that, I need the width and the height for those guys, right? So two of those, width times my height, right? And I just need the bottom after that. So it's just the bottom, this guy down here. And that's going to be the length times the width, right? So only one of those. So only one of those plus a length times a width. And that's going to give me my surface area. Okay, so now I'll come drop down and I'll start putting in some values. So my length is 6 and my height over here is 3.5. Okay, so two of those. Okay, two of my width, which is again 3.5. Let me just make that more visible. 3.5. And I need that height, which is 3.5 as well. And then I need these guys here, right? My length and width, which is a 6 and a 3.5. 6 times a 3.5. Okay, so that should do it for me, as long as I don't mess up with my calculations, right? So let's see, if I do a 2 times a 3.5, that's a 7, and then 7 times 6 is 42. Okay, and let me try that again. So I have a 7 there, and times a 3.5. So I'll do a 3.5 times 7, 35, 21, 22, 23, 24, right? 245. Okay. Let's see. Oh, I've got the decimal, right? So 24.5. And then a 3.5 times a 6. Okay, so there's 30, 18, 19, 20, 21. Don't forget the decimal. So a 21. Okay, and that should do it. Let's add them up. Okay, so a 24.5 and a 42. I'll put a 0.0, and a 21, and I'll put a 0.0. Okay, just to keep everything together. Right, there's a 4, 5, 6, 7, and then a 6, 7, and an 8. There it is. So 87.5 units or inches, and it's squared, right? Surface area. And there you go. So that's how much cardboard is needed. Okay, so cardboard needed. Okay, so 87.5 squared inches of cardboard needed. Let me just put an of there, of cardboard needed. And there is my answer. Okay, now, as promised, I want to do another one here. So we're going to cruise on up to this problem. This one's more complicated. That's why I wanted to hang out in here. So the roof of a small building is in the shape of a square pyramid. That's interesting. Okay, so the cost of the shingles for the roof is $15 per square foot, right? All right, so let's see. The cost of shingles for one of these triangular faces is $675. Okay, so I'm going to go into ratio chart land, right? So let's say cost dollars per square foot. So let's say square foot and money, right? So 1 square foot is $15. And for one face, they spent $675. So that's going to go over here and under the money. So the question is, right, what is this guy over here, right? So how many square feet is one triangle? So I can look over here and say, hey, I can divide by 15 to get one. So I'm going to divide by 15 over here. So there's my 15, 67.5, right? And okay, so that's going to go 4 times, right, for 60. I'm going to get my 7, bring down that 5. It's not a very good 7, sorry. And that'll be 5 times, right, for exactly 75. Okay, so a 45 goes in here. So one face, right, the area of one face is, let's see, is 45, right? So 45 square feet, right, for each face, right, is the area, right? Okay, so I'm good. Let's see. I'm good there. The cost of one triangle. Oh, I'm sorry. Wait, that's the cost. No, that's the square footage, right? Yeah. All right. So now what they want here is the perimeter of the base. Okay, well, the perimeter base, I need this distance all the way around, but I don't know any one of these guys. I don't know this guy, but wait a minute. It's the same as this guy, right? What I do know is the area of one of these triangles, right, is this guy here. So I suppose if I use the area for a triangle, I can figure this out. Huh. So the area, according to my calculations, is 45, right? And I have my 1/2, and I'm looking for that base because I want this value, right, all the way around. And then they gave me the height. That's the key to this game. They gave me a height of 7.5. Okay, so now what I can do is have some fun here. So algebraically, what I can do here is multiply this by 2/1. Here's why I want to do that. I know that if I take 2 and I multiply it by 1/2, that they essentially eliminate themselves, right? So 1/2 times 2 is 1, and then 1 times b or 1 times 7.5 is the same thing, doesn't change anything, but it does change things over here. So I need 2 times 45, which is 90. So this guy doubles, and I got rid of that 1/2, which was nice. And now I'm left with a 7.5b. Okay, well, here now I'm going to divide each side by 7.5. 7.5. Okay, and I'm going to be left with my value of b, which is that base. I just have to pull this guy off, right? So if I write him over here, little 7.5, I can't divide by a decimal, so I'm going to multiply both of these guys by 10, turn him into a 900, and him into a 75. So once I have that, put a 75, sorry. Now I can divide. Okay, so let's see. So this is going to go 0, that's going to go once. Right, that's going to be 15. Put this guy down there. That goes twice for 150. Oops, and he's done. Okay, so my base is 12. So my base is 12. What is this, feet? Should be feet, I think. Let's see. Yep, 12 feet. Okay, so now that I have my base is 12 feet, I can find the perimeter by going all the way around, and they're all 12. Okay, so perimeter, I'm making a big mess here. Perimeter is going to be the 12 plus the 12 plus the 12 because it's a square bottom, right? So there's your 24, and another 24 from those guys. So 48 feet, right, perimeter. There you go. Okay. So that's the deal, folks. Boy, that was a lot of work in there. Okay. I hope you enjoyed that. And I guess my advice to you is to take your time, see if you can draw things out and play around and see what they want. But read carefully so you know what they're giving you so that you can work with what's there. All right. So thanks so much. Take care. And don't forget, math rules. So long.